Okay, so the first thing that we're going to do is draw a normal transverse wave on a string. How does the transverse wave look on a string? One wave cycle. Okay, so let's cut this in half to make this look semi-pretty. Right, crest, trough. That is one wave cycle. Does everybody agree?
Yes.
Okay. I want to know if this were a standing wave. I'm just going to draw the incident wave of the standing wave, not both sides of it. Does everybody understand? Okay. The areas that touch equilibrium are called what? Nodes. Maximum displacement is antinodes. Very good. All right, why am I doing this? Well, now I want you to look at the standing wave that's in your open-ended tube. Okay, and then our equilibrium point is halfway through, right? So we're going to take a highlighter or marker or whatever you want, and we're just going to go from node to antinode. All right, because we know we always have antinodes at the open ends of the tube or pipe or column, etc. No, I always go up first. So on our wave at the top of the page, now I want you to highlight from node to antinode. Okay? At the top of the page, we're highlighting from node to antinode. Why are we doing that? Well, I want you to realize that in the closed pipe, at the first harmonic, right, the fundamental frequency, this is the first harmonic, how many wave cycles do I have? Do I have a whole wave highlighted? Do I have half of a wave highlighted?
Yes.
No. I only have a half of a crest, right? Half of a crest highlighted. So that's only 1/4 of a wave. And that's important because when we're talking about a closed pipe, we're only going to get quarter waves. Everything is going to be in quarters. Okay, so the first harmonic is going to be 1/4 of a wave. All right, we're using this equation still, L equals N over, but it's N over 4 because we're in quarter waves instead of half waves. Okay, so when I find the L of the first harmonic, I plug in 1 over 4 times the wavelength. And I only have 1/4 of a cycle. Now, because a closed pipe has a special vibration or special resonance, I'm only going to get the odd harmonics. Only odds. I will never have a second harmonic. I'll never have a fourth harmonic. I'll never have a sixth harmonic. Because it forces you to have a node right at the beginning, right, at the closed end, you're only going to have odd. Thank you. Okay, I'm highlighting the incident wave. It's the way that the wave is resonating in the tube, right? It forces you to have a node at the closed end. So you will never get even harmonics because of the forced node. right? And because you're getting quarter waves the whole time. Okay. So when I ask you what harmonic is the next highest harmonic after the first, you would automatically go to what? The third. The third harmonic is next. Okay. Because we only get the odds. If I ask you what's the equation to find L, you would say what? Yeah, 3/4 times the wavelength. So how many cycles are in the third harmonic? 3/4. 3/4 of a cycle. Okay, we have one crest, right, which is half of a wave, and then half of a trough. Okay, if you look at the wave at the top of your page, I went from node, antinode, node, to antinode right here. And this is where I stopped. So I only have 3/4 of a wave. Okay? So, some things that we need to remember. We only get quarter waves. Or cycles. We only get the odd harmonics. What do you mean by odd? 1, 3, 5, 7. That means n will only be 1, 3, 5, 7, 9. Okay? Whenever you're using these two equations.
Why exactly is that the third harmonic? What happened first? If you understand what I'm trying to ask. Oh, because that's the closing, right?
No. The last thing I want you to remember, that's like a little bit of a trick, is how to know or how to recognize what harmonic you're in. The easiest way to determine the harmonic number is by looking at the number of quarter cycles. Okay? So if you go from node to antinode, that's 1 quarter cycle. Then you go antinode to node, that's 2 quarter cycles. Node to antinode, that's 3 quarter cycles. So if I count the number of quarter cycles, what harmonic is that? It's 1, 2, 3, third harmonic. Okay? Okay? So the number of quarter cycles is your harmonic number, or n. So now we look at the next highest harmonic. What would be the next highest after the third harmonic? Yeah, the fifth harmonic is the next one. Okay, so you're adding on. If you notice from the first harmonic, I had a half of a circle, or half of an oval, if you will. And then the third harmonic, I have 1.5 ovals. Okay, so I added an oval, right, to draw. To go to the fifth harmonic, I'm going to add another oval. So that's going to be 2.5 ovals, or circles, whatever you want them to be. Does that make sense? And they get smaller. So we got to do that. This is the tricky part. Not bad. Not bad for freehand. Okay, and then highlighting, just like we always do, the incident wave just to see, to visualize what we have going on. We always, always, always have an antinode at the open end, and a node always, always, always at the closed end. Okay. What is the equation for L? Yeah. My A got a little excited. The last thing that we need to know is the same thing we talked about with an open pipe. Everything after the first harmonic is a multiple of the fundamental frequency. Okay? All frequencies after the first are multiples of that first. For example, if I told you the frequency at the first harmonic is 200 hertz. So if I said f of 1 equals 200, find f of 5. Okay? Well, everything is a multiple. That means you're going to multiply if I'm going up in harmonics, right? So what's 5 times 200?
1,000.
Exactly. So that would be 1,000. Okay? And vice versa. If I told you the frequency of the fifth harmonic was 1,000, what's the frequency of the first? You would divide by 5. Okay? That's it.